Welcome, this is Algebra 2, Semester 1, Unit 1, 5, quadratic formula. Hopefully you remember it from Algebra 1-1. It is, I'll tell you the story that I remember it by. Students taught this to me. It is a negative boy, couldn't decide whether to go to a radical party or b squared without 4 awesome chicks because it all gets over at 2 a.m. Okay? We actually plug in the values for each of those positions from the standard form of the quadratic equation. So my question is, when would the solutions be imaginary? Let's go back. What causes an imaginary number? Hopefully you're saying it's the negative underneath the radical. So look in the quadratic formula, where's the radical? So what would cause it to be imaginary would be if this equals a negative number. Well, this happens to be called the discriminant. So you're going to hear me talk in class a lot about discriminants. Because the discriminants tell us everything, whether it be imaginary or real. Whoops. It just went off camera. Oh, I didn't. Okay, so if we look at that discriminant, b squared minus 4ac, if we look at just that, and it's greater than 0, it's positive, whoops, it's positive, that tells us it's not an imaginary number. So our number of solutions would be real, and because the plus or minus out front, it would be 2 real, because it would be a plus or minus positive number. Now, if the discriminant's equal to 0, does it make sense we don't have a plus or minus 0? So if it's 0, then there's only one real solution, because it would leave it with the numbers out here. That would consist of 0. That would be nothing there. Now, if the discriminant is less than 0, it's negative. Well, we know any radical with a negative underneath now would be, it is a plus or minus radical negative, so it would be 2 imaginary. Okay, in the equation, I just want to solve a couple and show you. Value of the discriminant, well, here is my a value. The a is always in front of the x squared, that's 1. We have no b value, because remember, ax squared plus bx plus c is our standard form. There's no x value, so b is equal to 0, c is negative 1. So b squared would be 0, maybe I'll write that up here, b squared minus 4ac, 0 minus 4 times 1 times negative 1. It ends up being positive 4. Now if we think back, it's got the square root around it, plus or minus square root, positive 4, we've got the 0 out front, plus or minus the square root of positive 4 would be plus or minus 2. Okay, so let's look at how we can solve it over here. Going up our PIMDAs, add 1 to each side, would end up with x squared equals 1. Square root of x, x equals plus or minus 1. So now we might go, well, why did we get 2? We forgot that we have a 2a underneath from our quadratic formula. 2 times a is 2, so it's plus or minus 2 over 2, which equals plus or minus 1. On a graph, how would that look? If we were to graph it, this is transformed down 1 so it cross right here, and 1 squared is 1. So it crosses the x-axis right at +1 and -1. Okay? Next problem. If we have x squared equals 0, using the discriminant, the b is 0, -4 times a is 1, but now c is 0. All over 2 times 1. Okay? 0 minus 4 times 1 is 4 times 0 is 0. 0 minus 0 is 0. 0 over 2 is equal to 0. There's no plus or minus on 0. And square root of x squared is x. Square root of 0 is 0. So what this is saying is on this graph, the vertex is touching right at 0. Okay? Now let's get down to this one. Here my b value is still 0. -4ac. Remember, I'm really just looking at, I should say plus or minus. I'm really just looking at the discriminant. Oops. I was doing the discriminant. Ah! Okay, negative b plus or minus b squared minus 4ac. Okay, so we end up with a radical -4. That's what I'm trying to get to. And that is an imaginary number due to that negative. We would get the negative out as I. 4 comes out as 2, so it's plus or minus 2i. Here, we're solving, we would have x equals -1. Oops, x squared equals -1. X equals plus or minus I. Now again, you might go, oh, but we got 2i over here. Again, we've got to remember that it's 2 times a on the bottom. So 2 times 1. 2 goes into 2 once, so it's a plus or minus 1i. Now, how does that look in the graph? Well, we go back to our transformations. It's up 1. It's actually not crossing the real number line at all. Okay? Are these solutions real or imaginary? I'll be honest, I wouldn't use the quadratic formula on this. I would actually solve it. So I draw my line, subtract 4 from each side. Here's my dude. And I get x squared equals -4. Square root x equals plus or minus square root -4. X equals plus or minus 2i. And now I would write down, these are 2 imaginary solutions. It's a positive 2i and a negative 2i. Okay? Are the solutions real or imaginary? Give the solutions. Here I would use the quadratic formula. So there's my a value, my b value, don't forget it's a -4, and c value. X equals a negative boy. Couldn't decide whether to go to a radical party or b squared without 4 awesome chicks, because it all gets over at 2 a.m. First, to discover whether it's imaginary or real, I would only do the discriminant. So b squared, that would be 16 minus 4 times 1 for the a, 13 for the c. 4 times 13 is 12, 52, times 1 is 52, 16 minus 52, 36, it's at -36, so it is 2 imaginary. Now I go ahead and find them. X equals negative b, negative, and then we have a negative 4, so that'll make it a positive 4, plus or minus. Now, what is radical negative 36? Hopefully you say 6 is the root of 36. So we have 6i over 2 times 1, which would just be 2. Now I distribute that out. X equals 4 over 2 plus or minus 6i over 2. X equals 2 plus or minus 3i. That is a true solution. Don't be freaked out when it's a complex number. We're into that now. Okay?